Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss decoder. Let's begin. What is decoder? Decoder is a kind of data processing logic circuit, that is a combinational logic circuit that converts an input data into output signal, such that one of that output lines will be activated for only one of the possible combinations of the inputs. A block diagram of a binary encoder. If we prefer n bit inputs, n bit inputs, therefore at output we have 2 to the power n output lines. On this basis, we categorize the decoder as 2 to 4 decoder, 3 to 8 decoder, and so on. Here we discuss about two kind of decoders, that is 3 to 8 decoder and BCD to decimal decoder. First one, 3 to 8 decoder. As its name indicate, this is one kind of logic circuit that converts an input data into output signal, where one of that 8 output lines gets activated for only one of the possible combinations of 3 inputs. It has 3 inputs and 8 output lines. In truth table, inputs, 3 inputs named as A, B, C. So the possible conditions, taking 3 inputs, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. 3 inputs. So the possible conditions, 2 to the power 3, that is 8 number of possible conditions. And then at outputs, it is 8 number of output lines. The output lines are named D0, D1, D2, D3, D4, D5, D6 up to D7. Inputs, outputs, three inputs, A, B, and C, 8 number of outputs, D0, D1, D2, D3, D4, D5, D6 and D7. So, the high values of the outputs here D0, 1 all are 0. Next D1, 1 all are 0. Here D2 is 1. There 1. One, 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 all are 0. That is the truth table for 3 to 8 decoder. Look carefully to that of truth table. For the inputs 0, 0, 0, the high value of outputs D0 is 1. Next D1 as high value 1, possible inputs are 0, 0, 1. Therefore, when we write the Boolean expressions taking into consideration to that of particular truth table, so the Boolean expressions are written. For 0 we use the primed, for 1 we use the unprimed. First one, for D0 high value is 1. From the truth table first D0 1, possible inputs 0, 0, 0. So, A dash, B dash, C dash, A dash, B dash, C dash. Next for D1 1, possible inputs 0, 0, 1, A dash, B dash, C, A dash, B dash, C. D2 here 1, 0, 1, 0, A dash, B, C dash, A dash, B, C dash. D3 1 here, 0, 1, 1, A dash, B, C, A dash, B, C. Next D4 1, 1, 0, 0, A, B dash, C dash, A, B dash, C dash. Next D5 1, for that of inputs values 1, 0, 1, A, B dash, C, A, B dash, C. D6 1, for the inputs 1, 1, 0, A, B, C dash, A, B, C dash. Last one D7 1, for 1, 1, 1, A, B, C, A, B, C. Now we implement these Boolean expressions into the logic circuit. To implement these expressions to that of logic circuit, we have to use 8 number of AND gates and 3 not get for achieving their corresponding primes as a dash, b dash and c dash. The logic circuit. Eight number of AND gates. One, two, three, 4, 5, 6, 7, 8. The inputs, A is the input, this is A line. For A dash, use a NOT gate, so its output as A dash line. Next for B, that is B line. For B dash, use a NOT gate, that is B dash line. Next for C, that is the C line. For C dash, use a NOT gate, that is the C dash line. Now we construct the outputs. First for D0, for achieving D0, here we take D0. For D0, A dash, B dash, C dash join. A dash, this is B dash, this is C dash. Next for D1, A dash, B dash, C, A dash, B dash, C. D2, D2, A dash, B dash, C dash, that is wrong. D2, D2, 0 1 0, A dash, B C dash, A dash, B C dash, A dash, B C dash. Next for D3, D3, A dash, B C, A dash, B C. For D4, A B dash, C dash, A B dash, C dash. D5, A B dash, C, A B dash, C. Or D6, A B C dash, A B C dash. For D7, all are A B C, so A B C. This one is a 3 to 8 decoder circuit. Decoder circuit. Look that decoder circuit carefully. The circuit is very similar to that of the logic circuit for a 1 to 8 demultiplexer. But in case of demultiplexer, there will be an input line, which one is missing here. So we can say a decoder is similar to a demultiplexer without any data input. Here the data input line is missing. That's all about 3 to 8 decoder. 3 inputs, 8 number of outputs. Truth table. From that truth table, we construct the boolean expression. By using that boolean expression in the logic circuit for 3 to 8 decoder circuit, and it is similar to a multiplexer without any data input. Next type, BCD to decimal decoder. BCD, binary coded decimal system. So that kind of decoder is a combinational logic circuit that converts an input data into output signal, where one of the 10 output lines gets activated for only one of 4-bit BCD inputs, and it converts each BCD code to its decimal equivalent. So it has 3 inputs. It has 4 number of inputs and 10 number of outputs. In inputs, 4 number of inputs as A, B, C, D. Since it is 4 number of inputs, the possible conditions will be 2 to the power 4, that is 16. But here we consider 10 number of output lines, therefore we have proceeds the conditions up to 10 lines, where A stands for most significant bit and D stands for least significant bit. So the possible conditions 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1. And 10 outputs are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 4 inputs, 10 outputs. 4 inputs represent the BCD code. A stands for most significant bit, and D stands for least significant bit. Ten number of output lines, 0 to 9. The values are written here. 1 all are 0, 1 all are 0, next 1, 1, 1, 1, 1, 1, 1, 1 all are 0. Okay. From that of truth table we conclude for the BCD code 0000, for that of output is high, and for that of BCD code 0001 the output is high for 1. Taking that way, we write from the truth table for 0 all are 0, A B C D 000, 0 use prime, 1 unprimed, A dash, B dash, C dash, D dash, for 1, 1 0 0 0 1, so A dash, B dash, C dash, D, A dash, B dash, C dash, D. Similarly we write for 2, 1 0 0 1 0, A dash, B dash, C, D dash, A dash, B dash, C, D dash. Next for 3, A dash, B dash, C, D. Next for 4, A dash, B, C dash, D dash. 5, A dash, B, C dash, D. For 6, A dash, B, C, D, A dash, B, C, D dash. Next for 7, A dash, B, C, D. Next for 8, A, B dash, C dash, D dash. Next for 9 that is 1 1 0 0 1. So A B dash C dash D, A B dash C dash D. Now we construct the logic circuit, or we can implement that logic circuit by taking that Boolean expressions. To construct that logic circuit, we have to use 10 number of AND gates and 4 number of NOT gates. So 10 number of AND gates are used. 1 2 3 4 5 6 7 8 9 10. 4 inputs A B C D. A, let that be the A line. For A dash, a NOT gate is used, A dash line. Next for B line. For B dash, another NOT gate is used, that will be the B dash line. Next C line, NOT gate is used for C dash. For D, see the D line, and NOT gate is used for D dash. For achieving 0, A dash B dash C dash D dash. That line A dash B dash C dash D dash. The starting point. Next for 1, A dash B dash C dash D, A dash B dash C dash D. Next for 2, A dash B dash C D dash, A dash B dash C D dash. Next 3, A dash B dash C D, A dash B dash C D. Next for 4, A dash B C dash D dash, A dash B C dash D dash. Next for 5, A dash B C dash D, A dash B C dash D. For 6, A dash B C D dash, A dash B C D dash. For 7, A dash B C D, so B line for C D. For 8, A B dash C dash D dash, A B dash C dash D dash. Next for 9, A B dash C dash D. That is the logic circuit for BCD to decimal decoder. BCD to decimal decoder. For controlled decoding operation, means when we use a decoder in an electronic circuit, so how a decoder to be functioned. For that of controlled decoding, a signal is implemented. When the signal is on, then decoding starts. When the signal is off, the decoding is stopped. That can be controlled. We have to use a thing that is known as strobe. Strobe basically used for controlled decoding purpose. For that, we use an additional line for controlled decoding, operation. For controlled decoding operation, an additional line is used in input. This input is called strobe. So, when decoding starts, so that a strobe that is connected to all the AND gates. It is connected to all the AND gates. Therefore, when that strobe is activated by a binary signal, that gate is enabled according to that binary signal. Binary signal, if on, then it starts decoding, if off means 0, it stops decoding. For control decoding operation, an additional line is inputted. That additional line is known as strobe, that is connected to that of AND gates. So, here with the help of this video lecture, we understand the concept of decoder. Two kinds of decoder as an examples, as 3 to 8 decoder, 3 inputs, 8 number of outputs, truth table. Using that truth table, we expressed the boolean expressions. Taking these boolean expressions, we implement it to that of logic circuit, and a decoder is just similar to that of a demultiplexer without any kind of data input. Next type, as BCD to decimal decoder, it has 4 inputs and 10 number of output lines. By using that truth table, we expressed it in boolean expression. Taking these boolean expressions, we construct the logic circuit, it is BCD to decimal decoder. And how? we perform a control decoding operation. So, in technical term, strobe is introduced, which is nothing, that is an additional line to that of input which is connected to the AND gates. And when we implement the binary signals, as on decoding starts, as off decoding stops. So, with this useful and informative notes, let me wind up this session. Thank you.